All right, just a quick review of simplifying and operations with radicals. Remember that you can use factor trees or you can use perfect squares to simplify radicals. I prefer perfect squares. They're just easier for me to do the same every time, but I'll show you both with, say, the square root of 18. So the square root of 18, the biggest perfect square, this is the list, 1 squared, 2 squared, 3 squared, 4 squared, and so on. The biggest number over here that goes into 18 is 9. So that would become the square root of 9, and then 9 times 2 is 18, so the square root of 9 and the square root of 2. And then the square root of 9, I know what the square root of 9 is, it's 3. And then the square root of 2 is a decimal, so we're just going to leave it 3 times radical 2. So 3 root 2, 3 radical 2, remember that means 3 times root 2. Now, to do this as a square root, if you remember, the square root of 18 is the square root of 2 times the square root of 9. That should look familiar. We just did that. But say you don't notice that. That'd be square root of 3 and square root of 3. There's your pair. So square root of 3 times the square root of 3 is 3. And then you have that leftover radical 2, so you leave it radical 2. So I prefer perfect squares, so I'm going to finish these out with perfect squares. The square root of 125 falls right here. So if I'm going through and taking the square root and I work my way down, I just keep asking myself, does 81 go into 125 evenly? And so it doesn't until I get to 25. So the biggest perfect square that goes into 125 is 25. And 25 times 5 is 125. I'm not dealing with 125. I'm dealing with the square root of 125, or radical 125. So the square root of 25 is 5, and the square root of 5 is a decimal that I don't know, so I'm going to leave it radical 5. So the simplified version of square root of 125 is 5 radical 5. Biggest perfect square that goes into 72. So if I work my way down, 64 won't go into 72 evenly, 49 won't go in evenly, but 36 does. The square root of 36, and then 36 times 2 is 72, so the square root of 36 times the square root of 2 is the square root of 72. Square root of 36 I know because 6 squared is 36. The square root of 2 I don't know because it's a decimal, so I would leave it 6 radical 2, or 6 square root of 2. Then 180. Biggest perfect square that goes into 180 would take a little bit of work, but you work your way all the way down and you get that it's 36, and 36 goes into 185 times. The square root of 36 is 6 again, and then the square root of 5 is a decimal, so we're going to leave it 6 radical 5. Now again, you can go through and you can do your factor trees and you can find those pairs. If you have multiple pairs, remember that they multiply back together. Inside or outside. Okay, so if you have multiple pairs inside the radical, then they go back inside the radical. If they have multiple pairs outside the radical, then they come outside. Now, multiplying radicals, this goes along with what we were just doing. Multiplying radicals is if you take the radical of A times the radical of B, it is the same as taking the radical of A times B. Now, if you have X and Y that are outside of the radical, and A and B that are inside of the radical, you would multiply the X and the Y together, you would multiply the A and the B together, and then you would simplify from there. So this looks like this, the square root of 50 times the square root of 2. Now I'm going to write out all the steps, but you wouldn't have to write out all of this normally. The square root of 50 times the square root of 2 is the square root of 50 times 2. 50 times 2 is 100, and the square root of 100 we know is 10. Because 10 times 10 is 100. Okay? The square root of 3 times the square root of 6 is the square root of 3 times 6. Simplify that. Do the multiplication you can do. It's the square root of 18. We never leave anything unsimplified or unreduced, so we're going to simplify that out. The square root of 18 becomes the square root of 9 and the square root of 2, if you do perfect squares like I do. And the square root of 9 is 3, and the square root of 2 stays radical 2, because we can't simplify it. We don't. It's a decimal. A decimal squared is 2. Now notice this time we have 3 and 2 on the outside, so we're going to regroup. 3 times 2, and then the square root of 5 times 10. Okay, so now we're going to do the math we can do. 3 times 2 is 6. 5 times 10 is 50. but we can't leave that 50 there because 50 has a perfect square in it. So remember, this means 6 times the square root of 50 is 6 times radical 50, or 6 times the square root of 50. So it's 6 times. Then the biggest perfect square that goes into 50 is 25, and then 2. So 25 times 2 is 50. Okay, so now it's 6 times the square root of 5. The square root of 25 is 5. And then keep that radical 2, and 6 times 5 is 30. Notice how I'm very methodical about how I work my way down so that I can keep up with everything. Now be careful here. The mistake that people make here is they'll square the square root of 3, but they forget to square the 5. Remember that the 2, that exponent, is hanging onto the parentheses, so everything in the parentheses gets multiplied by itself. So it's 5 radical 3 times 5 radical 3. If we regroup that to our outside numbers, 5 times 5, and our inside numbers, 3 times 3, we get 5 times 5 is 25. Root 3 times 3 is the square root of 9. So we can't do anything with the square root until we've actually taken the square root. But the square root of 9 is 3, so now it's 25 times 3, because these are equal to each other. We're just working our way down. Okay, and then 25 times 3 is 75. But the biggest mistake people make is they get 15. They do the square root of 3 squared, but they forget to square that 5, and they would end up with 3 times 5 instead of 3 times 25. Okay, now what about division? The division, we're not actually dividing the radical. What we're actually doing is called rationalizing the denominator. In math, you are not allowed to leave a radical in the denominator. That's best practice. So we want to rewrite it without a radical in the denominator. So what we know is, based off what we just did right here, remember that the square root of 3 times the square root of 3 was the square root of 9, which was 3. And so what we find out is we can always do that. The square root of 5 times the square root of 5 is 5. The square root of 7 times the square root of 7 is 7. The square root of 10 times the square root of 10 is 10. You get the point, right? So we're going to use that fact, this right here, to get rid of that. Now I'm allowed to multiply anything by 1. So what I want to do is get rid of this radical 2. Well, I can't just go getting rid of it because I want to, but I can make an equivalent fraction out of this. So I'm going to multiply by the square root of 2 over the square root of 2. I'm multiplying by 1, but I'm using a 1 that's beneficial to me. Now I multiply across the top, multiply the numerators, and multiply the denominators. So 8 times the square root of 2 is simply 8 radical 2 over root 2 times root 2. Remember the pattern, root 2 times root 2 is 2. Now if you notice, this 8 is on the outside of the radical, and this 2 is on the outside of the radical. Those two can cancel, and 2 goes into 8 4 times, and you get 4 radical 2, just like you would simplify 8 over 2 without the radical. Okay, now this one, notice we have 10 root 3 over root 3. If you take that, notice if you have a root 3 on top and a root 3 on bottom, they cancel, just like if it had been an x and an x. So the nice thing is, in this case, those just cancel out and leave you with 10. Now, you could, if you didn't see it, you could go through the process. You can multiply by root 3 over root 3, and you would end up with 10 times 3 over 3, which is 30 over 3, which is 10. So you're going to end up with the same answer anyway. You might as well simplify from the beginning if you can at all. Okay, with this one, we've got that root 7. None of this cancels. That square root of 3 won't cancel that square root of 7. So we're going to multiply by our equivalent. We're going to create an equivalent fraction by multiplying by 1. The square root of 3 times the square root of 7 is the square root of 3 times 7, which is the square root of 21, over the square root of 7 times the square root of 7 is 7. Now be really careful. This is the square root of 21. This is 7. The square root of 21 is somewhere between 4 and 5. Okay? We don't know what it is off the top of our heads. We'd have to get it off a calculator, right? But it's somewhere between 4 and 5. It's not 21. So you cannot cancel this square root of 21 with this 7. Okay? Just like up here, You can only multiply if they were both outside the radicals or both inside the radicals. Here, you can only divide if they're both inside the radical or both outside the radical. This one right here, the same thing. That 4 and that radical 2 cannot be canceled, okay? So we have to get rid of that radical 2. Now, I don't care. We don't have to do anything with the 3 yet. We can just leave it because the radical is what we have the issue with. Multiply the numerators. 4 times the square root of 2 is just 4 radical 2 because you can't simplify that yet. And then we have radical 2 times radical 2 is 2, and 2 times 3 is 6. Now, you have 4 outside the radical, you have 6 outside the radical, so this 4 and 6 will reduce to 2 over 3. You can simplify that fraction or reduce that fraction by a factor of 2. And you end up with 2 radical 2 over 3. Or you could also write it 2/3 radical 2. That's also an acceptable way to write it. Now, what we're going to get into in the next couple of days is we're going to do some operations with this, which is why we wanted to give you some practice. So we've got these proportions set up that involve radicals, okay? Now, I want to help you out a little bit and shortcut this some in that you don't always have to cross multiply and then divide. For instance, let me show you. Normally, you would do the cross multiplication product. You would do cross multiplication product, right? Or the property. So you would cross multiply and you would get 2 times x is 2x, and 4 times radical 2 is 4 radical 2 because you can't multiply those together. Just like 4 times x is 4x and 2 times x was 2x, right? So we couldn't actually do anything, so we just rewrote them together. So we couldn't do anything, so we just rewrote them together. And then you would end up dividing by 2, right? To get rid of that 2, cancels here. This 4 and this 2 cancel to 2 here. And you're left with x is equal to 2 root 2. Now, what I want you to see, though, is it would save us a little bit of time. You notice that this 2 just went back where it was. So why move it in the first place? We want to get x all by itself, okay? So when x is already in the numerator, already where it wants to be, it's already on top of the fraction, then all we need to do is multiply this cross product and then divide by 2. So we would do 4 root 2 over 2, and we would have ended up right here in one less step. Same thing here. Now, look at 14. Notice we did a problem like this just a second ago. See that 6 root 3 over root 3? Well, I already know that those can cancel out, so I'm just going to go ahead and get rid of them. Then I'll cross multiply. Okay, well, there it is right there. So if I cross multiply, what I'm doing is multiplying both sides by 5, right? So those will cancel, leave me with x is equal to 5 times 6, which is 30. The radical 3's canceled out, and I'm done. So there is a benefit to seeing what you can cancel first. I can't cancel anything here because that 6 won't cancel that root 3. Don't rationalize it. We don't need to rationalize it. Let's just multiply. Now we're going to rationalize in just a second. Let's multiply. So if I cross multiply that, I end up with x is equal to 18 divided by radical 3. Now, we talked about it. We can't leave that way. So we need to rationalize that denominator. Okay, so let's create an equivalent fraction by multiplying by root 3 over root 3. Now we have 18 radical 3, multiply across the top. Root 3 times root 3 is 3. Notice the 18 and the 3 will reduce and cancel out. 18 divided by 3 is 6. 3 goes into 18 6 times. That leaves me with x is equal to 6 radical 3. Okay, with number 16, this square root of 6 will not cancel with that square root of 2. This is in the radical, this is outside. So we just need to cross multiply and then divide. We get x is equal to the square root of 30 divided by 2. Well, that 2 and that 30 cannot be simplified either. There's no need to rationalize because there's no radical in the denominator, so I stop. That's my answer. Okay, now on 17, you might see it and you might not, but you can cross multiply and then simplify, or you can simplify and then cross multiply. I'm going to simplify first and then cross multiply. So 14 over 2, I can simplify that. That's 7. Well, then just cross multiply. You get that x is equal to 7 times the square root of 2. Now what if you didn't see that? Okay, no big deal. X over square root of 2 is equal to 14 over 2. So say you cross multiply, then you're going to do 14 times radical 2. So we just rewrite it because that's all we can do. 14 radical 2 over divide by 2. Well, 14 over 2, 14 divided by 2 is 7. And you would end up with 7 radical 2 either way. It's just this way was a little bit quicker. Okay? Remember, this radical 2 and that 2, they don't cancel. One is inside the radical, one is outside, and you can't do that. Okay? Now, on this one, you're actually going to have to divide. And if x is on bottom, then you actually need to divide too. It's the easiest thing to see. So if you need to just continue to cross multiply the same way all the time, then do that. But on this one, I am actually going to cross multiply because of that 3x makes it a little bit different. So 3x times 2 is 6x and equals radical 3 times radical 3 is 3. Right? It's the square root of 9, which is 3. Divide both sides by 6, and you would get x is equal to 1/2. Simplify. Always simplify your fractions. Okay? So simplify if you can, and then cross multiply, and save yourself some steps by multiplying the side that doesn't have the part of the multiplication that doesn't have the x. Remember that you can do things with the two numbers that are inside the radical, and you can do things, multiply and divide the numbers that are outside the radical, and we rationalize denominators and not leave radicals in the denominator.